Hey guys, this is Naveen here. Welcome back to Naveen Automation Labs. And today we are going to talk about something very important for interview point of view. We are going to talk about what is time complexity. It's very important thing for the interviews. Either you are applying for as a developer or as an automation engineer, as a SDE or SDET. Everyone should know about what you mean by time complexity, how to calculate, what are the different ways of calculating, how exactly we can create a time complexity graph, as well as how to create and derive the time complexity in the form of big O of n. So let's see, what do you mean by time complexity? So a basic definition, time complexity is a measure of how long an algorithm takes to run as a function of the input size. The more and more input size you provide to the function, it will take more time. It depends what kind of algorithm that you are using. So we typically want algorithm that have a low time complexity. Obviously everyone wants that whatever the algorithm, whatever the logic that I have written, it should take less amount of time. If you are increasing the input size also, if you are giving more data also, then again it should have a less amount of time, means the low time complexity, as they will be faster and more efficient. There are several different ways to measure time complexity, but the most common is by using big O of notation. That is called big O notation. You must have heard about ON, O1, O log n, ON square and all such things. So big O is a standard notation, is a way of expressing the time complexity of an algorithm. So it's not about only Java or Python. It's nothing or not specific to a specific programming language. It's a concept of programming to calculate that how much optimized code that you have written and how exactly the time complexity is getting calculated. Doesn't matter that you have written the code in Java, Python, JavaScript or any other language. It depends that what kind of code that you have written, what kind of algorithm that you have written, and how exactly the time complexity is being calculated over here. So it will tell you how the runtime of an algorithm grows as the input size increases. How exactly the runtime execution is taking less amount of time or more amount of time, or it means the time complexity is so high that this code is not at all optimized and we have to optimize for that. So here are some common time complexities ordered from the best to worst. So O1 is the constant time, the runtime of the algorithm. It stays the same regardless of the input size. So in today's session, we are going to talk about what is O1. Later on, we will see ON, log n, n square, n cube, 2n and everything. And we will see some other really good examples also, like a linear search, binary search, bubble sort and everything. And then merge sort will give you O of n log n. We will talk about the binary search also, which will give you the time complexity of O of log of n. But today we are going to talk about, let's see, big O of 1. I'll give you a better example. For example, let's say you go to this particular function, and here in this function, what do you see? That I have just created one sum function. This is in Java, and this function is taking two parameters, a and b, and then it's giving total is equal to a plus b and returning it. So if I call this particular function, so let's say I'm just calling it and I'm passing 10, 20. Okay, and then 10, 20 will give you the addition of these two numbers. So let's see, I'm writing S1 is equal to this, and then in the next line, and then I'm just printing S1 over here. So what is the time complexity of the sum method? So you are getting the result of 30. It's fine. But in order to calculate 30, how much time it took? And then I cannot say that 5 seconds or 2 seconds and 3 seconds. It depends on the machine. But I really want to calculate that what is the time complexity for this. So let's do that. So let's see, this a and b is taking as an input parameter. So this 10 will be given to a, 20 will be given to b. So both will be executing only once. So I'll say, okay, find 1 and then plus 1. Then total is equal to a plus b. Then total will be calculated a plus b. And this a plus b will be 30 will be given to total. So let's see, this line will be executed. Line number 7 will be executed only once. And then it's returning the total as well. So there I'll again say, okay, fine, plus 1 only. So if you calculate, this is giving you 4. So if I denote with the big O, I'll say, okay, fine, the time complexity of this simple function, the sum function that I have written, that is O4. But what is 4 here? It could be 5 also tomorrow if I add, let's see, more calculation or more number of lines of single line that I add over here, more variables I created over here, and then more input parameters. It could be 7 also, it could be 10 also, it could be 40, 30, it could be anything. But we have to simplify in the form of what? How many times this line is getting executed? How many times this line is getting executed over here? So if you notice, the 10 will be given to A only once, 20 will be given to B only once. These two lines also will be executing only once. So we just need to check that how many times the same line of code is getting repeated or not, is getting executed again and again. There is no for loop, there is no while loop, nothing. The overall time complexity for this entire function is O of 1, which is a constant time. Okay, I'll say like that, because it could be any number. It could be more, it could be 40 also, 400 also, 400 lines of code that you have written. So this number is denoting what? This number is denoting that, okay, fine, how many times each and every line of code will be executing over here. You can see that it will just executing. It will be executing only once. This will be executing only once. These two parameters will be initialized only once. There is no for loop, nothing. So that's why, to make it simplify, I'll say O of 1, that is a constant time. So this is a standard for the constant time. We write O of 1 instead of saying O4 or O400 or something like this. We simplify, write it in the form of O of 1. So some other example, let's see if you check that, okay, what is the time complexity for this? Let's see, I have created one array. In this particular array, for example, let's see, I have 1, 2, 3, 5. And then I really want to print system.out.println, give me the value which is available on a specific index. So let's see if I'm passing, okay, fine, give me the value is available on the second index. So this is 0, this is 1, this is 2. So are we writing any for loop or something here? Are we just Java what exactly will do? It will just go there in this particular array, and whatever the value is available on the second position, it will just fetch and then it will give it to you, or it will just print it on the console. So that's why it's giving you 3. So Java don't need to perform any other for loop or something. Java will say, okay, fine, at this second index inside the memory, when this particular array will be initialized, simple go to the second index, and whatever the value is available, just pick that. You don't need to traverse from here to here. This is not, the 3 is not available at the random position. So I don't need to go to the memory each and everywhere, because the index is already passed over here. So I simply say, okay, fine, go to the second index and then fetch the value. That's it. This is just like one big apartment is there, and then you just go to the specific apartment in that particular unit, number 101, and then fetch the value from there. That's it. So that's what, if you see, the accessing an element in an array, that is also called O of 1 over here. If someone is asking you what is the time complexity of a simple variable, if I declare, let's see, integer a is equal to 10, what is the time complexity of this? This is also big O of 1. It will be executing only once. Same thing, what is the time complexity for this algorithm? This is also O of 1, just a constant time over here. Now, at the time of interview, people will ask you, can you create a graph of constant time? So how will you do that? Graph is also very important. We will see some other graphs also in upcoming chapters, but what you just simply say, okay, fine, you just create x-axis and the y-axis. Y-axis is defining about the time, that how much time it will take, or how much CPU computation that you have to perform over here. I would say, let's see, computation here. All right, and this is the input size, that if you add more and more data, then, or more and more input elements that you are giving, in that case, how much time it will take. So today we are going to talk about only big O of 1. Then in that case, the big O of 1 is a constant time. So if you know simple mathematics, the O of 1 will take a constant time, means it will just create a graph like this. So it will just use it. I will draw the line over here like this. So this is O of 1, a constant time. Doesn't matter how much input size that you are giving. I mean, the input size, obviously there is no concept of input size, because this is getting executed only once. There is no for loop, nothing. And then, because in for loop, what will you write? I is equal to 1 and I less than 100, then 100 times the loop will start. If you write I less than 1000, then 1000 times loop will start. But here, as such, we don't have that. So it will be a constant time over here. So I would say this is the big O of 1 over here. So at a time of interview, if someone is asking, give me the time complexity graph for big O of 1 like this. So this is big O of 1 over here. Later on, we will see O of n, log n, and O(n) square also later on. We will see that in the next chapter, in the next video. So I hope this is clear. We will continue in the next video. Please check that. This is something very important, and let me know in case of any issues. Now in this video, we are going to talk about what is a linear search, or you can say ON time complexity. So what is ON time complexity means? The linear time complexity. The runtime increases linearly with the input size. It means the more and more input size that we are giving to the specific algorithm, it will take more time at the runtime. For example, if you see this particular simple for loop, I have written a variable n equal to 10. Now we are starting a loop from I equal to 1 up to less than equal to n, and n is 10. So we know that this loop is going to print I am a Batman 10 times, and then we are appending I over here, and same I will be increased n number of times, means 10 number of times over here. So when you run this particular program, here you can see that the same statement at line number 38 is getting printed 10 times over here from 1 to 10. So what is the time complexity for this? Now this n equal to 10 could be any number. Tomorrow it could be 100 also. Then in that case, if I'm running it, then the time complexity will be O of 100. You can see that. So it's printing from 1 to 100. Tomorrow it could be 1000 also, and then 10 millions also. Any number that you really want to use, a long number or some big decimal number or big long number also, you can simply write it over here. But for example, let's see, I'm running it with 10. So I know that it will be executed 10 times. So let's see, if I really want to calculate the time complexity, so at the time of interview, you have to derive a formula, a linear equation formula for that. So for example, let's see, we start from here, and we know that, okay, integer I is equal to 1. This guy will be executing only and only once. So I'll say, okay, 1. And then the next statement I'll be adding with plus, and then I less than equal to n. It means this statement will be executing, in this case, 10 times. If it is 100, it will be 100 times. If it is 1000, it will be executing 1000 times. So I don't have a fixed number, because this entire for loop, this algorithm is actually based, and it's actually dependent on n over here, the value of n. So in that case, I'll say, okay, fine, in a very generic term, I'll say n number of times this I less than equal to 10, this statement will be executing. Then the condition is satisfied, then it will execute this print statement. This is also going to execute n number of times. In this case, let's see, 10 number of times. So I'll say n number of times, because I'm deriving a general formula over here. Then it will go and then increase the value of I by 1 n number of times once again. So if you calculate all these n's, so can I say that this is a 3n plus 1? So this is giving you what? This is giving you a linear equation, right? Mathematically, if you present, this is called a linear equation, right? And if you really want to see the time complexity of this, so time complexity, what we do, you see plus 1 over here. Plus 1 is coming because of this I is equal to 1. You think about it, if I'm writing, let's see, 10,000 or 100k times also, and more and more numbers that I'm giving, n is equal to this, what is the significance of this? For example, let's see, this entire algorithm is taking around, for example, let's see, around 90 seconds to execute, or let's see 5 minutes to execute, assume that. But this, what is the significance? What is the role of I is equal to 1? How much time this guy is I equal to 1 is taking? This is taking, let's see, for example, around 0.0001 second. That's it. So 5 minutes overall algorithm is taking. What is the contribution of I is equal to 1 in terms of time consumption? It's only 0.001 second, because it's getting executed only and only once. This is giving you almost a constant time here. So in that case, whenever we have to simplify the formula, we keep ignoring and keep avoiding or keep removing the constant values from here. So I'll say, okay, fine, after removing plus 1, I'm getting only 3n over here. Now there are n number of statements. Also I can write, let's see, if I'm writing more and more lines of statements here, then it could be, this factor also could be different number over here. So I'll remove this 3n also from here. Then finally I'm getting n. So I'm removing, I'll keep removing the constant, this 3 constant also from here. So finally the time complexity, it is denoted with big O of n here. So this for loop is giving you what? A linear equation graph, a linear equation time complexity that is denoted by O of n, you can see. That's why you see here O n linear time, the runtime increases linearly with the input size. So tomorrow if I have added, let's see, more and more data in it, then in that case, instead of 5 minutes, it might take 10 minutes also, 30 minutes also. So more and more number of inputs that I'm giving, in that case, more data that we are getting it over here. Let's take one more example, a linear search algorithm that we do. It's a simple algorithm. It says that, okay, traverse the array. So I'll provide one input array and then match the key element with the array element. Whatever the key that you are passing, you just match it. And then if the key element is found, return the index position of the array element. So I'll simply say array of I is equal to key, then you return the index of that particular key. Otherwise you return -1 here. So what is the time complexity of this linear search? The time complexity of this linear search is also big O of n. So if you really want to run this particular, call this particular method, let's call it and let's see. So I'll do one thing. Let me just comment it out. This one, I don't want to execute this n number of times. I simply call this particular method, that is a linear search method. Linear search method, I'm going to call it from here. Linear search says, okay, fine, you give me one array. So before that, I'm going to declare one array. Let's see, this array is equal to some array that I'm writing. Let's see, 1, 3, 44, 22, 56, 77, and let's see 11, like that. And then what is the key? The key also I'm passing integer key is equal to, I'm looking for 56. Give me the index of 56 in this particular array. So we know that index, this is 0, this is 1, this is 2, this is 3, this is 4. It's available on the 4th index. So I'm passing array and this is the key and I'm calling it. And then whatever this method will be called, whatever it's giving, and then I'm storing in some integer. For example, let's see, integer index is equal to this. And I really want to know system.out.println, print the value of index. It means in this particular array, what is the index of 56? So let's run it and let's see. The index of 56 is giving a 4 over here. That is absolutely correct. You can see this is 0, 1, 2, 3 and 4. So what kind of algorithm it is? This is a linear algorithm. How many times it will be executing? In linear algorithm, each and every, you can see I is equal to 0, each and every element will be compared with the expected key that you are looking for. So first it will go and check with 1 is equal to 56, 3 is equal to 56, 44, 22, and then finally the moment I see 56 is equal to 56, immediately I'll return that particular index. If nothing is matching, I'll return -1 over here. So in that case, what is the time complexity? It is getting executed from 0 to up to 4. So I can say O4, or in a very general term, I can say O of n, because tomorrow I can look for 11 also, or more elements are there. I can look for a specific value which is available on a specific number, on a specific index. So in a very linear term, I would say this is giving you a big O of n here. I'll write it like this, right? Okay, but there is one thing. If I'm looking for, let's see, key is equal to 1 in this particular array, I'll directly pass 1 over here. So I'm looking for key 1 in this particular array, and the moment it sees, okay, array of I is equal to key, it means the first element 1 is equal to 1. Yes. So then no need to proceed further, immediately return I over here, I is equal to 0, and 0 is what? The index of 1. So in that case, this is called this is called what? In that case, I'm getting big O of 1 over here. Okay, so this is called best case scenario, or best case time complexity, you can say that. And then I'll say that big O of n is, okay, worst case time complexity. So wherever we have to calculate the time complexity of any algorithm, we always consider that in the worst case. Obviously in the best case, it will give you a better result. But in the case of worst case, what is the time complexity? That is denoted with O of n. That is called a linear equation for this particular algorithm. So if someone is asking you the interview question that, okay, for the linear search, what is the best case? The best case is O of 1, and what is the worst case time complexity will be O of n over here. So if you see this 3n plus 1, it's giving you a linear equation. And if you draw the same thing on the linear equation, where exactly it will go? So it will go like this. I'll just draw a simple diagram or simple line over here. So this will give you O of n over here, something like this over here, like that. Okay, so I'll write this is big O of n here, where n is the size of your input. So the more and more input size that you give, the more time it will take over here. So that's why if you combine the lines, let's see, if you have only 5 inputs, then you can just check that, okay, it will execute around, let's see, around 0.5 seconds. Let's see, these y-axis is the time in number of seconds, and this is the input size. But suddenly, let's see, your input size is around 50, then in that case it will start taking more time over here. Then suddenly if you say that, okay, now the time the input size is around 5000, and then it will take around, you know, around 40 seconds or 50 seconds, like that. Then if you have more data, let's see, 10,000 or 15,000, then in that case it will increase over here like this, right? So this is a linear graph equation. People might ask you at a time of interview that what is a linear graph for the O of n? Can you please draw it? So this is how you have to draw it, like this. I hope it's clear. So in this video, we are going to talk about what is ON square or quadratic time. So if you see the definition, that is, we are going to talk about ON square. It means the runtime is the square of the input size. It means the more and more input that you are giving, it will automatically will be n square times. For example, input size is n, then in that case, the time complexity will be n square times. That equation is also called mathematically quadratic equation. Some example like bubble sort is one of the best example for the ON square time complexity. So let's see how exactly we can calculate the time complexity. For example, we have nested loops and one outer loop and one inner loop, maybe 2 for loops that we have in the nested form. When we have one while loop and internally we have one for loop, then in that case also we will get the ON square time complexity. So I'm writing a simple basic code. For example, let's see, I'm writing a for loop here, and then I'm writing with I is equal to 0, and then I'm writing let's see, I is less than equal to 5, and then I plus plus, something like this. And then I'm creating 2 more variables. For example, integer m is let's see, is equal to 5, and then I'm writing integer n is equal to 5 also. So I'm saying instead of 5, this algorithm, this for loop is actually based on m here. Okay, then what I'm going to do, I'm writing another for loop inside this particular outer loop. Let's see, j is equal to 0, and then j less than equal to n over here, and then j plus plus. And then I'm doing something. For example, let's say I'm just appending I and j together. So for example, I'm just simple writing I plus j with the, like this, with one space also I'm appending. And once the inner loop is done, I'm just putting a new line, creating a new line. So what will be the output of this program? First, let's see when you run this, and here you can see that the output is coming in this particular format. And if I remove the ln also from here, because I don't want to generate the new line after the first statement, then the output is coming like this. You can ignore this one. This is some other code that I have written here that I'll show you in the sometime. But here you can see that it's printing from 00 to 55. If I include, let's say, up to 9, and m is also 9 and n is also 9, then in that case it is running this kind of pattern, 00 to 99 pattern is coming. So if you observe one thing, let's say again back to 5 and again back to 5, if you observe one thing here, that, let me just remove this particular code for time being. I equal to 0, I is less than equal to m. This is the outer loop and this is the inner loop. So for I is equal to 0, this entire inner loop j equal to 0 up to 5 it will be executing. And then again I will be increased by 1. Then again for I is equal to 1, for loop will be running from j equal to 0 to up to n. So likewise, for every value of I up to 5, the value of 4, the value of j inside the inner loop will be keep running in that case. So how to calculate the time complexity in this case? So in order to calculate that, let's see, you have to derive the formula at the time of interview. For example, let's see, you can just ignore this because this will give you 1 plus 1 only. So let's start from here actually. I equal to 0 for the outer loop. So I'll do one thing for the outer loop. I'll put in a bracket here like this. I equal to 0, how many times it will be executing? It will be executing only once. And then I'm saying that I less than equal to m. It means this condition is based on m. If m is equal to 5, it will be executing 5 times. If m is equal to 10, it will be executing 10 times. So I'll say, okay, it will be executing n number of times. The moment the condition is satisfied, immediately it will come to the inner loop. So for inner loop, I'm going to do a product over here, the multiplication. I'm going to write in a separate bracket here like this. I'm not going to add because these 3 statements will be added, but the inner loop will be multiply with the outer loop here. Okay, so in that case, let's see j equal to 0. How many times it will be executing? It will be executing once again 1 plus j less than equal to n. This guy also is actually totally dependent on n. N means the number that you have written. So let's say I'm saying that, okay, it is getting executed n number of times. Then the moment condition is satisfied, it will print this particular statement. Then I'll say, okay, fine. This statement also will be executing n number of times. This number could be anything, 5, 50, whatever it is. And then after that, the value of j will be increased. So I'll say, okay, fine. The value of j also will be increased n number of time here. Okay. Then once this is done, then after that it will generate a new line. Okay, fine. Then the new line also will be generated. So let's see, for time being, I'm just ignoring generation of the new line. Okay. Then again, I will be increased. So I will be increased once again. So I'll writing the I part over here because this first bracket is for the I, this for the outer loop and this is for the inner loop. So here I can see that, okay, yeah, I will be increased once again n number of times. So I'm saying, okay, fine, it will be increased n number of times over here. Okay. And then if you really want to include this line also, because this line is part of the outer loop, it's not written inside the inner loop. So I'll say, okay, this new line also will be generated n number of times over here. So that's what, if you simplify the formula over here, what will you get here? In order to simplify it, so we will just do the simple calculation. I'll write here, okay, fine, this is like, I'll say 1 plus 3n. Then again, I'll say this is again 1 plus 3n over here. Then if you multiply both the things together, then I'll say that, okay, this is 1 plus 3n plus, so this is 1, then 3n, then again, I'm saying once again 3n plus what? 3n multiplied by 3n, that will give you 9n to the power 2. It means 9n square. And then again, you simplify this formula. So I can say that if I create a quadratic equation, 9n square plus 6n plus 1. Okay, plus 1 here. So what kind of equation it is? This is a quadratic equation, right? Mathematically, this is not a linear equation. This is called a quadratic equation. Okay, so people might ask you at the time of interview, ON square is the quadratic equation. That's what this is giving you a equation like this, 9n square 6n plus 1. And then I'll do one thing, that I'll take again, I simplify this. I'll say that, okay, plus 1, I can ignore it from here, right? So because this is the constant that we have already discussed, that we have to keep removing the constants from here, because this plus 1 is coming because of I equal to 0 and j equal to 0, that will be executing only once. And it is like the value or the significance of I equal to 0 and j equal to 0, it is like almost negligible. If this entire execution, let's say, is taking around 5 minutes to execute that, this is taking around, let's see, 0.0001 second. So I don't consider to calculate the overall time complexity for this is almost giving you the constant time. So that's what we have to keep excluding the constant from here. So if I exclude that, finally what exactly I'm getting, 9n square plus 6n that I'm getting. Then I'll do one thing. I'm just going to take a common value, let's see, 3n over here. So this will give you again 3n plus what? 3n plus 2. This is what we are getting, right? So 9 square plus 3 multiplied by 2, 6n that we are getting. Then again, I'm going to exclude 2 from here. So what exactly is left? 3n multiplied by 3n, that is giving you 9n square. And then again, you remove the constant. So finally, you are getting O of big O of n square that you are getting. So what kind of equation it is? This is again a quadratic equation. Finally, we are getting it. So instead of writing O n square 6n plus 1, we make it simplify that, okay, yeah, this is O n square. So whenever you see 2 for loops or 2 nested loops, then in that case, it will be O n square. Let's see, tomorrow if I write one more for loop inside this inner loop, then it will become on cube times. That also we will discuss in upcoming chapters. So right now this is on square. Now if on square, if you really want to draw over here in the graph, where exactly in the graph it will go. So in the graph, guys, obviously on square is expensive as compared to on. So it will go in the left hand side of the graph. It is not a better performance, because more and more data that you have, then it will go in this direction, in a parabolic direction like this. So if you draw for on square, so let's see where exactly it will go. So it will go like this. Okay, let me just quickly draw this. Okay, slightly parabolic like that. It will go like this. Okay, so here this is, I can say this is on square, or maybe you can make it more towards left hand side, but let's see, I don't have much space here, so I'm just, this is for on square times like this. So that's what, if you see, if you compare with the data with on, which is a linear time for let's see 5 input size, it is not much impacted here. On square will take around, let's see, more than 1 second, and on was taking around 0.5 seconds. But let's see, the more and more data that you have, on was taking around, let's see, 5 seconds, or maybe let's see 7-8 seconds. Then in that case, this on square will actually intersect over here, and then it will just go here. So it will take around, let's see, 20-25 seconds. Same thing for the 5000 of data. You just see that the input side is 5000. Then in that case, on was taking around, let's see, for example, around 200 seconds over here, but here it will take, on square will take, you can imagine, okay, it is coming somewhere over here around 800 seconds or something like that. So now you can see that on square is quite expensive, will take more time, and it's not a good performance when your algorithm or your whatever the code that you have written, which is giving you on square of time. That's why we avoid to use 2 for loops, but it's not like we cannot use it, it's completely avoidable. No. So on square will give you the graph like this. Any practical example of on square? Yes, we have the bubble sort. You know, bubble sort is very straightforward, that you, in bubble sort, you have to check the next adjacent value, and then you have to keep comparing, and if it is both are not equal, you just need to swap the element in that case. Okay, like this. So this is just simple algorithm that I have written. This is the array, and then I have created one method, and then I'm passing this particular array, and I really want to sort with the help of bubble sort mechanism. So in bubble sort, first inner loop that I have started from I equal to 0 up to length of -1, and then again j equal to 0 up to length of -1. It means length minus I minus 1 over here like this. And then I'm just swapping the element, simple array of j, putting inside a temporary variable, and then j plus inside the array of j, and array of j plus 1 is equal to temporary variable. So if array of j is greater than array of j plus 1, it means the first element is actually greater than the next element or adjacent element. Then in that case, you have to swap the element. So once this entire for loop is done, you can see this is the outer loop and this is the inner loop. This will be executed, let's see, m number of times. This for loop will be executed, let's see, n number of times. So it is giving you a kind of m multiplied by n matrix. Okay, I would say m multiplied by n. So let's see, both are running n number of times, or maybe some number of times. So I can say, okay, fine, if m is equal to n, then in that case n square times. Right, so in the very generic form of formation, I can say, okay, fine, this is giving you on square times over here. So whenever you have to traverse matrices or bubble sort, or 2 for loops, or 2 while loops or inner loops, while inside the for loop and for inside the while loop, it will always give you on square time, and you can just calculate like this. You can just keep simplifying the formula. Ultimately, it will give you a quadratic equation here. It is not giving you a linear equation. Quadratic equation means n square value, you will be getting it here. Okay, so I hope this is clear about the on square. So in this video, we are going to talk about what is on cube, means cubic time complexity. So cubic means that the cube of the input size. If the input size is equal to n, then the time complexity will be on cube. For example, multivariable equation, it's a very famous interview question that we will take this example as well. And then whenever you are using, let's say, triplet nested loops, 3 nested loops that you are using back to back, that will give you ON cube. And at the time of interview also, people might ask you to calculate or derive the formula for the ON cube time complexity. How to do this? Pretty simple. So let's see, this is the method that I have written, where method name is a triple nested loop, and we are passing one parameter n, that is the input size. So what exactly I'm going to do that, I'm going to write one for loop, and then I'm going to create, let's see, for example, x is equal to, which is starting from, let's see, 0, and then x is less than n, and then I'm writing x plus plus. And then once again, I'm writing another for loop inside this loop, and then I'm starting, let's say, integer y is equal to 0, and then y less than n, and then y plus plus. Then I'm writing another for loop, that is, let's see, z is equal to 0, and then z less than n, and then once again n plus plus, z plus plus here. Okay. And then let's see, I'm printing some statement here. So this is integer z, and I'm printing one statement. For example, let's see, system.out.println, and then let's see, I really want the output like this. The output should be 0 0 0, and then I'm writing 0 0 1, then I'm writing 0 0 2, 0 0 3, 0 0 4, like this. Okay, so I want this particular format, and in the next line it will be, the j will become 1 there in that case, so it will become 0 1 0, like this, then 0 1 1, then 0 1 2, 0 1 3, and then 0 1 4, like this. So what exactly I want, I don't want to add these three numbers, I want to concatenate them. So I simply say, okay, this is x plus with some no string, plus y plus again no string, plus z plus, and then I want that particular space as well in that case. So I simply say, okay, fine, put that space over here, and I want all these three triplets number should be written in the same line. So I don't want to print with the ln, and after this, the last loop, I want to generate a new line over here as well, like this. So let's see, this is a simple method, that is what I have written. Now I'm going to call this particular method, where I have to pass the value of n, which is, let's see, n is equal to 4 in that case, or n is equal to 5, let's see, in that case. So what will be the output? Let's see. So in this case, if I'm running this application with the Java application here, you can see that we are getting the output like this: 0 0 0, 0 1 2, 0 0 2, 0 0 3, 0 0 4, 0 1 0, 0 1 4, like that, and then it will keep giving you all the different combinations up to the last number will be 444 over here, because we are not using less than equal to n, we are using less than n. If you are making it 6, then the last number will be 555 at the end. Here you can see that, right? So how exactly this is working, because the inner loop will be executing first against y is equal to 0, and the second loop will be running completely against x is equal to 0, like that. So first time what will happen, x is equal to 0, x less than n, n is what, let's see, in case of 6, condition is satisfied, then inner loop will be executed, that is the second loop will be executed, y is equal to 0, condition is again satisfied, then it will go to the third loop, that is z equal to 0, z less than equal to less than n, that is again satisfied, and then it will concatenate x plus y plus z. So what will happen for y is equal to 0, this entire loop will be executed. Once this is done, then only y will be increased. Once this entire for loop will be done, then only the outer loop will be increased with x plus plus. So that's what this is called, what, 3 nested loop that I have written: loop number 1, loop number 2, and loop number 3. So what will be the time complexity? How will you calculate that? So for example, let's see the first loop that I have written, which is getting executed. Let's see, x is equal to 0, which is like 1 plus x less than n. It will be executing, let's see, n number of times. And then after that, the second loop, once again, the second loop is also y is equal to 0, which is getting executed 1 plus n. And then the third loop, which is again, that is the third inner loop, which going to be executed, z is equal to 0, it means 1 time, z less than equal to less than n, again n number of times it will be executing, and then it will print this particular statement also. So let's see, I'm saying it will print n number of times, then the z will be increased by 1 n number of times, so I'm saying plus n over here, then y will be increased by 1 n number of times, then in that case again n number of times I have to add in the second bracket, And then the first one, the first loop, which is represented by this particular bracket, and then x will be increased by 1 n number of times plus n. So when you calculate all these equations together, so if you see that, it will give you something like this, that is 1 plus 2n, once again 1 plus 2n, and then it is 1 plus 3n over here, right? Something like this, 1 plus 3n. If you really want to include this thing in the second loop also, you can include that. So it will, let's see, plus n once again over here. So this is actually giving you 1 plus 3n. So when you calculate all these guys together, so it is like this, 1 1 1, right? Or you can just calculate these two brackets first, and then you can calculate with this. Okay, you can multiply with this. So ultimately what will you get? Once 2n multiply by 3n multiply by 3n, it will give you n cube here, right? So it will create the equation something like this. When you remove all the constants from here, it will give you the n cube plus n to the power 2. Okay, I'll write it here, n cube plus n square plus n plus 1. Okay, so it will give you the equation that is called a cubic equation. So that's why this kind of complexity will give you a cubic equation. In the last on square we have seen that is a quadratic equation. Before that we have seen on, that is linear equation, and o1 is the constant time equation. So this is a cubic equation, right? So how will you draw this cubic equation, this particular mathematical representation on the graph? So on the graph it will somewhere over here, this is like really time taking complexity, I would say, the algorithm. So let's see, I'm just representing with this particular color, let's see a pink color or something, and then I'm going to draw it from here. So it will actually go like this. It is more left hand side of the on square, and then it will be like this. So this is on cube. So you have to draw the things at a time of interview also. This is o n to the power 3 times. So tomorrow if you have, let's see, fourth loop also inside this particular loop, that will be o n to the power 4, because ultimately it will create another bracket, and then all these 4 n's will be multiplied, then it will represent n to the power 4. So it will be like n4 n cube plus n square plus n plus 1, like this. So that's what the overall time complexity here, the big O of n to the power 3 here. Okay, like this. So that's what this is called, a cubic equation, on cube here. Perfect. So this is like whenever you have to print the triplet format like that, in that case you can just use this particular time complexity, which is a very rare case. Okay, anyways, so the one more example we will talk about, that is multivariable equation, that how to solve this. This is again an interview equation. For example, let's take this example. Let's see, you have to calculate equation here, that is 3x, okay, plus 9y plus 8z, which should be equal to 79. So you have to find out all the combination of x, y and z, and when you multiply with 3x, 9y, 8z, and then when you add them together, the calculation should be, the addition should be 79 in that case. So how many combinations that you can create it over here? For example, let's say if I ask you that if I add, let's see, x is equal to 0, then in that case it will be 0. Then if I say that y is equal to 8, or y is equal to, let's see, 7, so 9 multiplied by 7, that will give you 63 plus, and let's see, 8 multiplied by 2, then in that case 8 multiplied by 2 is equal to 16. So this is giving you what? This is 6 plus 3 is equal to 9, and 6 plus 1 is equal to 7 over here. So this is giving you 7. So how many combinations that we have created, that x is equal to 0, y is equal to 7, and then 8 is equal to 2. So you have to find out all the combination where when you add this equation, it should give you 79. This is an interview question. So first said that from this particular equation that we have found, that x is equal to 0, comma, and then y is equal to 7, comma, and z is equal to 2. So this is the first set which is fitting with this particular equation. So how will you solve this? So this problem, which can be solved with on square also, it can be solved with on cube also. Let's see how to solve it. So I'll do one thing, I'll just take this same for loop over here, or I'll do one thing, I'll just go into create another method over here. See, this is a very famous interview question. So don't get confused. Let's see, I'm writing one other method, public static void, let's see, multi number equation. Okay, something like this. And then the number that I'm going to pass it from here. So let's say integer n from here. And then I'm going to write this entire for loop once again. I don't want to print this thing and forget about this also. So I'll say, okay, x is equal to 0 up to n, y up to n, and z up to n. Right? Now see this carefully. This is the equation that we have to use. 3x, 9y, and 8z. So I'll just put a condition that if what? 3 and the product of x, like this, 3 multiplied by x plus 9 multiplied by y plus and 8 multiplied by z, if it is equal to what? Whatever the number that you are expecting, 79, then in that case I got x, y, and z combination. Then I'll do one thing. I just simple write system.out.println, and then I'll print the value of x. Okay, I'll print the value of x plus with some space plus y plus with some space and then plus z over here like this. So this will give you the combination like 072, something like this. If you really want to put a comma, let's put a comma actually. So 0, comma 7, comma 2, like that. So let's see how many combinations we are getting from here. So I'm going to call this particular function. I'm going to comment it out this one, and I'm going to, let's see, call this function, and I'm passing n is equal to 10, right? So up to 10, you have to find out all the combinations. Okay. So let's see how exactly it is giving. So here you can see the first combination is 072 that we have already seen. Likewise, you can see 145, and you can cross check that 3 multiplied by 1, 9, 4, 36, 36 plus 1 is equal to 37, and 8 multiplied by, so 36 and plus 3 is equal to what? 39 plus 40 is equal to 79. So 145 is getting satisfied over here. So likewise, it will satisfy all the numbers here. So this is a solution that is giving you the equation and the combination of x, y, z, which is satisfying this particular equation. So they might give you any equation which is equal to 79 or whatever, and that is the predefined. You just need to use this equation in the if condition here and find out the multi-triplet number for this particular equation which is justifying it. That's it. So that's a simple solution for this. So if you see this, the time complexity of this particular algorithm is also O(n) to the power 3 over here. That is a cubic time that we are getting here, right? Because again, n multiplied by n multiplied by n. So that will give you n a cube with this particular condition also. But ultimately it will be O(n) cube as well, right? So that's what O(n) cube is more and more expensive because see, if you really combine the dots here, that for let's see for 5 set of data, it is somewhere taking around 10 seconds. But if you see that O(n) square is taking around 1 second only. But if you have, let's see, input size is around 50, which is merging over here around more than around, you can say around 70 or 80 seconds, but O(n) square is taking around only 20 seconds over here like this, right? So the O(n) cube is more worse. So you just keep moving the graph O(n) to the power 4 or O(n) to the power n, something like this. You can draw it over here like that. Okay. So this is about the O(n) cube cubic time. Thank you so much. So in this video, we are going to talk about what is log n, that is logarithmic time. You must have heard about that log n is better than log O of n, or which one is having the better performance. Are you getting the better performance with the log n, with O(n) or O(n) square? So first, let's see what do you mean by O of log n or logarithmic time. So in order to understand that, logarithmic means the runtime increases logarithmically with the input size. And some example like binary search or the quick sort, you can take that. I'll give you one practical animation example, a very good example of the binary search. And then with this animation, you will understand that what exactly, how exactly this binary search is implemented. So for example, if I refresh this particular entire page, and if you see that there is an array, And the size of the array, you can see it's starting from 0 to 31. It means the size is 32. It means 32 elements are there in this particular array. And I'm looking for example, let's see any element that where exactly it is available. For example, let's see this 88 element I'm looking for, which is available at the 0th position, or maybe 538, which is available on the 19th position. So I have to find out the specific element is available on a specific index or not. If it is not, then return -1. Otherwise, you give me the specific index of that particular element. So how will you do that? So with the binary search, first of all, binary search will work upon the sorted array. Make sure that, okay, your all the elements are already sorted here. And then you can search for the specific element. So what exactly binary search will do? Binary search will divide this entire array into two parts. For example, let's see if I'm looking for 88, and then first it will divide this entire array into two parts. It means 0 to 31, and 31 divided by 2, which is giving you 15 over here. And then now we have to check the element either before 15, it means between 0 to 14, or between 16 to 31. And then on the basis of some condition, we will decide, okay, fine, I'll go with the left hand side part. It means from 0 to 14, I'm going to look for that particular element. And then again, I'll divide this entire array, now 0 to 14, into two parts. And then again, the size will be in that case 7. Then again, I'll check I want to go to the left hand side or the right hand side. Then in that case, I'll again divide that particular array from 0 to 7 into two parts. Then we are getting, let's see, 4, 4 to 2. And then finally, we are getting 88 over here. So you will get a better understanding when I show you in this particular animation. For example, let's start with the 88 with the binary search, not with the linear search. And then let's click on binary search. And here you can see we are looking for element is 88. So see, first it is actually dividing into two parts. Now element is from 0 to 14. Again, it will be divided into two parts. Now 0 to 7. Then again, it will be divided into two parts. That is now between 0 to 3. Again, it will be divided into two parts. Like 4 divided by 2 is equal to 2 now. Now between these two elements are available. Then again, the array size is 2. And then finally divided by 2 once again. And then finally, we got that particular element. So how many iterations that we have performed? It's not like we are performing each and every value that we are checking from 0 to 31. So it's not like we are writing a loop from 0 to 31 or 31 times that we are iterating over here. Let's take some other number. For example, let's see if I'm looking for 678 over here. So I'll start with, okay, 678 and click on binary search once again. So again, this is the lowest index. This is the highest index. We are looking for 678. First, again, it will be divided into two parts. Then it will decide, okay, fine, I'll go to the right hand side part and then again divide it into two parts. Then again, divide by two parts. So it will keep dividing. Then it will decide, okay, fine, I'll again go to the right hand side part. Now the cursor will move to the right hand side part. And then finally I got again divided into two parts. And then finally I got 678 over here. So hardly 3 to 4 iterations I have performed just to find 678. That's why it's giving you the element 678 is found actually on index number 22, right? If the specific element, let's see, available at the last index, let's try with the 907 as well. Let's go with that. With 907, again, lowest index, highest index, entire array will be divided into two parts. Now we have decided, okay, fine, we will go with the right hand side. Again, it will be divided into two parts. Now we just need to look into that particular array. That's it. And then again, keep dividing into two parts. So every time we are dividing the entire array by 2, then again, the size is now 4, 4 to 2, and then 2 to 1 finally. And then after 2 to 1, we are finding that element is available at 31st index over here. And then the 31st index will be returned over here. I'll tell you the logic, how exactly it is working. Now let's see if element is not available at all. I'm looking for, let's see, 8777, something like this. And then I'm going for the binary search. So let's see how many iterations it is performing. Again, divide by 2. Then 8777 is actually greater than the mid element. Then it will go to the right hand side. Again, divide by 2. Then again divide by 2. So now from 27 to 31, it will go and check. Again divide by 2. Okay, now we have only 4 elements. 4 divided by 2 is equal to 2. Then again, finally 2 elements are left. I mean 2 indexes are left. And then we have reached at the last element also. Now I cannot divide by 2. Then in that case, I did not find anything. Then in that case, it will return -1 over here. It will say element not found. So how exactly this particular algorithm is working? Now let's see, I have an array. For example, let's see, this is the array that I have. And make sure that guys, that this is the array which is already sorted array. Okay, so binary search will work always on the sorted array. Sorted array means the elements are already sorted. For example, let's see, I have some elements like 1, 2, then 3, 4, let's see, 5, 6, 7, 8, and then let's see, 9 is also there. And then these are the 9 elements are available here. And then you see this is 0th index first, 2, 3, 4, 5, 6, 7, and 8. So in binary search, what exactly we have to do? First of all, that we have to check, okay, fine, I'll take two variables. Let's see, low variable. That is the lowest index is always 0. Then I'm going to take, this is my highest index, which is equal to what? Whatever the array length is there, the array length dot -1 that I'm going to take. So this is my lowest index and this is my highest index. So I'll take, okay, fine, this is my whatever the array dot length -1. In that case, this is my highest index. So this is giving you 8 over here. Okay. Then I'll do one thing. I'll start writing a simple, let's write a pseudo code. I'm going to write a while loop. And inside this particular while loop, I'm going to write if low variable is less than equal to high. Okay. Until this, I have to start a loop here. Then I'll exactly what exactly I'm going to do that. First, I have to calculate the mid of this particular array. So mid of this array is what? How will you calculate? So let's say I'm going to take one variable integer mid, which is equal to what? Integer mid is equal to whatever your lowest number and then the highest index number that is divided by 2, right? That will give you the mid. So in that case, 0 plus 8 is equal to 8 divided by 2. So this is my mid now. So I'll say, okay, fine, this is my mid. So mid is pointing to at this. It means mid is pointing to 5 and then the index is equal to 4 over here. I'll put a condition immediately that if my first condition that I'm going to write that if this particular mid is equal to the number that you are looking for. Let's see, the number that I'm looking for is equal to, let's see, 1. I'm looking for this particular one, right? So if is equal to x, then in that case, so for example, let's see 1 is directly available over here. Then in that case, I got my element and that's it. I don't need to proceed further. I immediately say, okay, fine. Then you return what? Return the mid, return the same index over here. It means mid is equal to 4 in that case. So immediately you return 4. It means 1 is available on the 4th index, but my 1 is available over here. But it could be anything, right? This 1 is available over here also. That is also possible that 1 is available here as well. Okay. So let's say if immediately we found the specific element on the mid position, then immediately you return the mid. Then I'm saying, okay, fine. Then otherwise, what do? Otherwise, you write one more else if over here. And then I'm checking that if array of mid. What is array of mid? Array of mid is what? Let's see, this is in this case, in this example, the array of mid is 5. Then I'm checking that if 5 is less than x, the number that you are looking for, we are looking for x is equal to 1 over here. So 5 is less than 1. No, 5 is not less than 1. Then in that case, just ignore this particular condition. But let's see if I'm looking for 9. If x is equal to 9, then in that case, 5 is what? Less than 9 in that case. If it is less than 9, then what should I do? Then I have to go in this particular direction. Then after mid, I have to start. So in that case, what should I do? Right now, the low, this low index is pointing over here and the high index is pointing over here. This is my highest index and this is my lowest index. So what I'll do, I'll just shift this particular low over here. It means shift this particular low to mid plus 1. So in that case, that's what, if the condition, this condition is satisfied, I have to go to the right hand side. This arrow means right hand side we have to go. It means then you do what? Then you write the low is equal to what? Mid plus 1. Okay. But else if your array of mid is what? If array of mid is greater than x, it means, let's see, in that case, if you're looking for 1, then in that case, what? array of mid initially was 5. 5 is greater than 1. In that case, what? In that case, yes, this condition will be satisfied. Then in that case, I know that, okay, I have to go to in this particular direction. So what should I do? It means this high, I have to shift it over here. So I'll say, okay, fine, high, you come here. It means mid -1 that I have to write. So in that case, I'll write mid -1 over here, right? Because the high mid initially was pointing to 5. So mid -1 is equal to 4 now. So that's what high is equal to mid -1. In that case, I'll be writing high is equal to what? Mid -1, right? And then if it means I have to go in this particular direction, in the left direction. Then in that case, if once the while loop is done, I found that particular element, but let's see that element is not at all available over here. Then after the entire while loop from here to here, then you say, okay, fine, you return -1. In that case, element is not found. So this -1 will say, okay, fine, element is not found in this particular array. Let's say I'm looking for 11. 11 is not there, right? So in that case, let's check this particular pseudocode. Is it really working or not? So I'm looking for 1 over here. Okay, so I'll check, okay, that mid is equal to what? So in that case, my mid is equal to 4. You can see mid is equal to 4 according to this algorithm. Then I'm checking 4 is equal to 1. No, 4 is not equal to 1. Then go to this particular else if. Then it's saying that array of mid is what? 4 is greater than 1. Yes, this is satisfied. It means where? Here you can see that this particular condition will be satisfied. It will not go to this particular condition because 4 is not less than 1. It will go to this condition. 4 is greater than 1. Yes. So it means high index is equal to mid -1. So what is my high index? Mid is what? 4 minus 1. So in that case, high will start pointing over here. Perfect. So what is the value of high? High is equal to 3 now. And what is the low? Low is equal to 0. So again, it will go and check. Again, the while loop will start. It will check low less than high. Yes, low is still less than high. 0 is less than 3. It will go and check, okay, what is the next value of mid? The next value of mid is equal to what? Again, 3 plus 0 divided by 2. It means 3 divided by 2, which is giving you what? Which is giving you 1 over here. Okay, 1.5 means 1 because 0.5 will be ignored in that case. So 3 divided by 2 is equal to 1. It means mid is pointing to where? Mid is pointing to the 2 over here. Then again, it will be divided by 2. And then finally, I got this particular element here. So like this entire algorithm, how many iterations is actually performing in that case? So if you really calculate, if let's see, for example, if there are, but let's see, if there are 32 elements are there, then how many iterations are there? It means length of the array is equal to 32 in that case. So every time we are dividing by 2. So let's see, this is the length is equal to 32. So I'll say, okay, fine. First, you 32 divided by 2 is equal to what? 16 in the first iteration. Then again, in the second iteration, the 16 is again divided by 2, which is equal to 8 in the second iteration. Then in the third iteration, again, 8 divided by 2 is equal to 4. Okay. Then in the fourth iteration, again, 4 divided by 2 is equal to 2. Just keep dividing it. 4 divided by 2 is equal to 2. And then in the fifth iteration, 2 divided by 2 is equal to 1. And then your element is actually found over there. So in that case, how many iterations we have performed? 1 to 5. It means 5 iterations we have performed if the array size is 32. So if array size is 32, can I say it is actually 2 to the power 5? It means 5 iterations is performing on the base of 2. So same thing if I'm asking that, okay, for 1024, how many iterations it will perform? It will perform around 2 to the power 10. It means 10 iterations only. So if the size of the array is 1024 elements are available, then it will perform only 10 iterations to find that specific element maximum it will perform. Then same case, if there are 32, 768 elements are there, then it will perform only 2 to the power 15. It means 15 iterations it will perform maximum. It will. That's it. So such a nice optimized solution, a search algorithm that we have in that case. So if you really want to generalize the formula, how will you generalize how exactly we can say this is O of log n? Because, for example, let's see, number of iterations are denoted by k. So I'll write, let's see, number of, in this the same formula, iterations is equal to k. right? So I'll say that if there are n input size, what we do, divide by 2 always, divided by 2 to the power k is equal to 1. We can say like that. Or if you simplify the formula, then we can say that n is equal to 2 to the power k. It means when you perform, see this 2 to the power k, this is also k, this is also k. So I'm just defining a generalized formula. It means 2 to the power k is equal to what? Number of elements, which is equal to n. So that is what I have written. 2 to the power k is equal to n. I have written. Fine. Then if I take the log both sides, so I'll say, okay, this is a log of n, which is equal to log of 2 to the power k. Then I can again simplify this. I'll say, okay, this is log n is equal to what? I can say k log 2 here. And let's see, both the sides, the base is 2. So I'm applying the base 2 over here like this. So can I say that the overall time complexity is what? The overall time complexity, I can say k is equal to how many iteration it is actually performing. It is performing log base 2 n iteration it is performing. Now this is what the time complexity like this. So if you write it like this, n by 2, then n by 4, then n by 8. So can I generalize that? Okay, n 2 to the power 0, n divided by 2 to the power 2, then n divided by 2 to the power 3 like this. So that's what I'm saying, n 2 power k is equal to 1. So n is equal to 2k. And like that, if I take both the sides log, so finally we are getting log of n over here. So if you see the simple binary search method over here, that is what I have written. It's taking, okay, you give me the sorted array and give me which element that you are looking for. And such a simple algorithm, lowest index is equal to 0, highest index is equal to array length minus 1. And then I'm checking if low less than up to less than equal to high. And then first of all, immediately you find out the mid. Mid is equal to what? Low plus high is equal, divided by 2. And then I'm checking if array of mid is equal to x. It means that element that I'm looking for, it's available in the mid position. In that case, in the best case scenario, you simply give me that mid position and return mid, and that's it. But if it is not available, then you check the next condition, that if array of mid is less than x, in that case, it means if less than x, then you have to go to the left direction. Otherwise, you have to go to the, it means low is equal to mid plus 1. Otherwise, high is equal to mid minus 1 over here. And that's it. So then if nothing is getting satisfied after the entire while loop, you simply return minus 1 here. So for example, let's say if I have a specific array, for example, I have this array, and then I'm calling this particular function binary search. So let's see, is it really working or not? I'm calling binary search. This is my array, and the x that I'm looking for, let's see, 3. And 3 is actually available 0, 1, and 2. So it should give you 2 over here. All right. So I'll store in some integer. Let's see, ix is equal to this. This is the index number of 3. So let's see, ix should be what? 0, 1, 2. Let's see, is it really giving you 2 or not? So now you can see it's giving you 2. If you're looking for, okay, fine, give me the index of something, let's see, 5. Then in that case, it's giving you 4. If you keep adding more numbers here, let's see, I'm adding 10, then 11, then 606. Then in that case, 14. Perfect. So this algorithm is absolutely working fine. This algorithm is a binary search algorithm, which is giving you the big O of log n time complexity. It will give it to that. Okay, perfect. But let's see, if you are not having the sorted array, for example, let's see if you are having unsorted array, then in that case, first you have to sort it and then only you can do that. So for example, let's see, I'm just going to comment it out. At a time of interview, if you are having the unsorted array, this logic will not work. It might give you the wrong result. So first you have to use what? Arrays class dot sort method. You can use it, pass the array. First you sort it and then apply the binary search over here. So then you apply the binary search. Okay, so first you sort it and then you apply for that. So let's see, I'm looking for once again 6. Then in that case, first it will sort, and then the 6 is the last element, means available on the 5th position. Okay. Okay, over here that we were discussing about, where exactly the log n will go. The log n will go to the right. So if you draw the O of log n, it will give you logarithmic graph, which is like somewhere better than O of n. So if you really draw this, it will go in this direction like that. So let's see, I'll just pick some other color this time, this one, and then it will go like this. Okay, somewhere over here, and then you just slightly, okay, and then it will just, after more and more elements, let's see if tomorrow, if you have 32, 768 elements are there, it will just perform only 15 iterations. So you have to draw the graph accordingly like this, and just below the O of n that you have to draw it. Remember this thing, don't draw the O of log n over here. Okay, not at the left hand side of O n. It always be the right hand side of O of n. So in this video, we are going to talk about the time complexity for O n log n, that is also called linear logarithmic time. It means the linear logarithmic time means the runtime increases with the input size and the log of the input size. The one of the example with the, you can see merge sort O n log n. So this is the combination, you can say O n plus log n, and then we combine them together, and then we will get O of n log n, and then we will see the time complexity graph also. But one of the example is the merge sort. So in this video, I'm going to talk about that. What do you mean by merge sort? How exactly it is giving you the on O and log n? So always remember, whenever we have to talk about the merge sort, we have to talk about the divide and conquer this particular array, and then we have to sort this particular array with the help of merge sort with the divide and conquer. It means first divide this particular array and then keep adding it. Conquer means keep merging it. That's why this is called a merge sort. So we are going to talk about a merge sort mechanism. Must say that is one of the best sorting algorithm, which will give you O of n log n, right? So I can say this is a combination of O of n plus O of log n. Also, you can say that O of n is coming because of the linear. We will talk about because of the linear equation we are getting it. On O of log n we are getting because of the logarithmic equation we are getting it, because we have to keep dividing the array. So that's what we have to, these kind of algorithms are called divide and conquer. So I'll write, this is merge the array once again. Divide means keep divide this particular array that you can see in my screen, keep divided by 2. So that will give you O of log n. So that's why this will give you, the divide part will give you log n, and the merge means keep doing the with the ON with the ON linear equation, and then keep merging the array into one part. So this is the formula that you have to remember, that these kind of things that we have to solve with the divide and conquer problem. So this is called merge sort. We will not write the code, but we will see how exactly it works. So these are the 8 elements are there, and these are totally unsorted array. And then I'm giving some indexing. Let's see, index number 1, then 2, then 3, 4, 5, 6, 7, 8 elements are there. You can start the index from 0 also. So what we have to do, we have to divide this particular array into 2 parts. Okay, so from here we have to divide this. So let's see, this is the first part and this is the second part. And the first part that we will get the first half, that is 7, then 5, then 2, and then 1. So I'll just write it like this. And then the next part is 9, 6, 3, and 4 here. Okay, so perfect. So first we will keep dividing, and then we will keep conquer. So what we will do first, let's divide until what? Until we get the only one single element in the array. So it will be a recursive method that we have to write. So what we have to do first, divide into 2 parts, and then again divide that part and that part into 2 parts. So once again, I'm going to divide into 2 parts, this also into 2 parts. So I'll say, okay, fine. I'm just going to divide with 7 and 5. And this is 2 and 1 over here, like this, 2 and 1. And then this is again 9 and 6. So I'll write it like this. And this is 3 and 4 over here, like that. Okay, once again, divide each and every part into 2. So once again, this will be divided. So this will become only 7, and this is 5. This will become 2, and this is a 1. This will be divided into 2 parts. So this is 9, and then this is 6, and then once again, this is a 3, and then 4 over here. So we have to keep dividing until you get only one single element in the array. Now you can see that we have reached at the last iteration, that is each and every array is having only one element. You can see 7, then 5, 2, and 1. So we have to keep dividing into multiple parts. Tomorrow, let's say right now we have 8 elements are there. So it will be 8 by 2. That's what it's dividing, like, okay, 4 elements here and 4 elements here. Let's do tomorrow, if we have nine elements, then in that case, it will be 5 elements here and 4 elements here. Like that also, we can do that. So no need to worry that if you have odd numbers or even number of elements, that's okay. Then it will just, let's see, in case of 11, then it will be 6 elements here and 5 elements at the left hand side. So, and then after that, just keep dividing into, okay, 2 parts. And then once we have divided, and we have to divide it till you have got the final element, that is the single element that you have captured. So now this is the division part is done. Okay, so till here that we have divided. Now what is the second thing? That second part is the conquer. Conquer means the merge. Now we have to start doing the merging part. So that's what I'm saying. This is a merge part, or you can say the conquer part also. Okay, so I'll do one thing. I'll just write all these elements that we have already captured, right? 7, 5, 2, 1 something. Now what we have to do, we have to keep conquering. But one thing you have to remember, that when we have to add or merge, you have to add it with the sorted mechanism. So what we have to do, we have to start keep creating the pair. So 7 and 5 will be merged. So which one is, so when what we have to merge? So merge means merge, but before merging, we have to sort it. So I'll write sort and merge. So here, then sorting and then merging. Remember this thing. So between 7 and 5, which one is the smaller? 5 is the smaller. I'm going to merge these two things. So I'll say, okay, fine. Then 5 will be added over here and 7 will be added here. Same thing between 2 and 1. 1 is the smaller one. So 1 will be added here and 2 will be added here. Then between same thing with 9 and 6, I'll say 6 here and then 9 here. And between 3 and 4, you don't need to sort because it's already sorted. Then in that case, it is a 3 and this is a 4 here. Fine. Then again, we have to keep merging it. So now I'm going to merge these two things. So what we will do here, when we merge that, right, you will get 4 elements, right? So what we have to, let's see, this is the left-hand side array and this is the right-hand side array, right? And let's see, this is represented by I index and this is represented by, let's see, J index. So what we have to do with I, we have to compare with J. So let's see, this is I0 will be compared with J0, and then we will check which one is the smaller one. The 1 is the smaller one, right? J0 is the smaller one. So 1 will be given over here first, and then we will remove this element from here, and then we will increase the index of J by 1, and J will moving to the next part. Okay, then again I0 will be compared with the J2 or J1 over here. You can say that with this. So 5 and 2, which one is the smaller one? The 2 is the smaller one. The 2 will be given over here, and then J will be moved to the next part. Now in the next part, we don't have anything. So we add a bigger number, a larger number over here. So for example, let's see, I'm going to add one infinity over here. Okay, then once again, and then once the 2 is shifted over here, right, then we will remove this 2 from here, and then we will add infinity. Then once again, I'm comparing with 5 with infinity. Which one is a smaller? Obviously 5 is a smaller one. So I'll write 5 here. So I'll add 5 here and then remove 5 from here. Then I'll increase the index of I to the next element. Then once again, the 7 will be compared with the infinite. So why are we adding the infinite? Because so that we can keep comparing the data, right? Which one is the smaller one and which one is the larger one. So 7 is again compared with the infinity. Which one is the smaller one? The 7 is the smaller one. Then 7 will be added over here. Same thing, we will do it over here as well. So let's see, once again, 6, 9, 3, 4. When we merge them together, we will get 4 elements. So I'm writing, okay, this is once again I, and this is J. This is I0 and J0. So I0 will be compared with what? 6 will be compared with 3. So which one is the smaller one? The smaller one will be picked first. And then I'm saying, okay, fine, 3 will be taken first, remove this array from here and increase the value of J by 1. So J will be moving to the next element. Then once again, 6 and 4, which one is the smaller one? 4 is the smaller one. 4 will be removed here, and then J will be moving to the next element. In the next element, we don't have anything. Then I'm going to add one infinity, a larger number over here. Then once again, 6 will be compared with infinity, obviously 6. Then in fact, no need to compare 9 with infinity. We know that now whatever you're comparing with the infinity number, that specific number will be the smaller one. So I'll just keep adding 6 and 9 over here without any problem. So, okay, this is also added over here. And then after that, these 2 elements are left. I mean, these 2 arrays are left. Then again, I'm going to merge them together. So I'm going to add conquer once again. Once again, this is I, and let's see, this is J. So 4 and 4. So I know that, okay, I'm going to get 8 elements over here. So I'll say, okay, 1, then 2, 3, 4, 5, 6, and let's see 8 elements. I'll be getting it here. But once again, this is what I0, and this is also J0. So first I0 will be compared with the J0 one by one like this. So I'll say, okay, I0, 1 is smaller than 3. Yes. So 1 will be added over here, and I'll just remove 1 from here. And okay, and this is I, and then I'll keep shifting I to the next element. I is pointing to the next element now. Then once again, 2 is compared with 3. Which one is the smaller? 2 is the smaller, so 2 will be removed from here and added over here. Then I will be increased over here. Then once again, the 5 and then compare with 3. Which one is the smaller? 3. 3 will be added here, remove 3 from here, and then shift J to the next element. Then once again, 5 will be compared with 4. 4 is the smaller one. 4 will be added over here. Then in that case, remove 4 from here and move the index of J to the next element. Then once again, 5 and 6 will be compared. So which one is the smaller one? This time I is the smaller one. It means 5 add over here, remove this 5 from here, and then move I to the next element. Okay, now I is pointing to 7 and J is still pointing to 6. Once again, 7 and 6 will be compared. Which one will be coming first? 6 will be coming first because 6 is a smaller one. Remove this from here, and then so keep removing and then keep adding it over here. Remove it and then add it here. So we have added here 6 over here, and then shift J to the next element, that is 9. Then 7 and 9 will be compared first. So 7 will be added here, and then the J will be towards to the next element. We don't have anything. And then in that case, I'll add some larger number, let's say infinity here. Remove 7 from here and add it over here. That is what we have added. Now we know that, okay, there is no point of comparing infinity and 9. We know that between infinity and then 9 is always a smaller number. And then we will add 9 over here. And that's it. Okay, and then we will remove 9 from here. So what exactly we are getting, if you see this array, 1, 2, 3, 4, 5, 6, 7, 9, that is what we have written over here, that 7, 5, this one array, this is the unsorted array. And now finally, after divide and conquer, what we have achieved, this is 1, 2, 3, 4, 5, 6, 7, 9. It means we have achieved complete sorted array over here. So this is what a sorted array, right? And what we have seen actually, we have seen conquer, but before that we have seen the division. So keep dividing and then merging over here. So that's what these kind of mechanisms, these kind of algorithms are called, divide and conquer. Okay, so that's what the divide, we have to keep dividing into 2 parts. It means first time, let's see, n elements are there. We have to keep dividing into 2 parts, then n by 4 parts, then n by 8 parts. So that's what, this is what we have already seen in the, just like in the binary search also, what we do, divide into 2 parts. So this is giving you log of n time complexity. But here, when you keep merging it, this is just giving you what? Merging to array, that is giving you O of n linear equation. So that's why when you combine them together, log n over here, like this. So that's why the time complexity will be this one. So if you see the time complexity graph, so O n log n, somewhere it will coming over here, guys. See this one. Okay, this is not better than O of n and O of log n. This is slightly expensive as compared to n and log n. That's why you see here, and this one also here, O n log n is coming towards left hand side of O of n. So, but still it's better than O n square and O n cube. And this example is what we have solved with the merge sort. In fact, merge sort in all the types, either it is the worst case scenario and the best case scenario, in the average case also, it will always give you O of n log n. And this is one of the most performance wise, one of the best sorting algorithm, that is a merge sort, which will give you O of n log n. Okay, so merge sort is the one of the best sorting algorithm. That is what we have seen, the simple thing here. In upcoming videos, I'll tell you the complete code also. We will write the pseudo code and then we will try to see that how exactly it is working. But this today, I just want to show you how exactly it is giving you the n log n time complexity. I hope this is clear. So far we have seen differences of time complexities and how to calculate the time complexity. For example, O of n, O of log n, what is constant time, what is O n log n, O n square, O n cube. Now these are called worst case time complexity. So if we divide the time complexity in 3 parts, so what we say that We can say best case possibility or time complexity, worst case, and the average case. Everyone should know about what do you mean by best case, worst case, and the average case. And when we write a algorithm practically, which one is that we have to consider, which one we have to take it a serious case, so that whenever we are writing any logic or any algorithm or any program, we just need to make sure that my code, that algorithm, is actually handling the best case, worst case, and the average case. But how exactly is it handling the worst case scenarios? For example, you assume that okay, there is a couple of some layman example. Let's talk about it. First of all, that the best case should be denoted by the that we have already seen with respect to big. A worst case should be denoted with the big O. Okay, so how to pronounce it? Big O, like this, like this. We have to use it like big O. We have to use it. Average case is denoted with big theta. Okay, I'll write it for you. This is a theta. Mathematically we use it, this naming convention or this notation that we actually use it. Best case is used with the omega, so this is like omega, so I'm writing this is with omega. Okay, so if you really want to calculate the best case scenario, in most of the books that you will see that omega of 1, like that. The worst case scenario we say okay, big O of n. The average case scenario means the theta of n, like this we have to use it. But let's talk about with some examples. For example, let's see there is a container, or let's see this is a bucket. In this particular bucket, there are a number of balls are available. See, these number of balls are there, or some elements are there, some balls are there. But you have to find out, let's see, this particular ball, this color ball. All right, you have to find a specific element or a specific element from the array. Then what will you do in the best case? The moment you come in this particular jar, in the first attempt itself, you find this particular element, it means the best case scenario, I found it. I don't need to proceed further. I don't need to iterate it. In the first attempt itself, I found that particular element. But same case, if you see the worst case, let's see this particular ball is available here. And then you are checking one by one, and then you have put, let's see, n number of attempts that you have done. And then after hundreds of attempts that you are able to find this particular ball, it's placed over here, or let's see, is available here in this particular container. So in that case, you have to perform n number of searches that you have to perform. Same case, let's see, in the average case scenario. In case of average, okay, fine, after let's see couple of attempts, you have found this particular ball is which is available here. Then in that case, let's see, it's taking around, let's see, n by 2 time or some n by m time it is taking. So that is called the average case. So best case means the moment we see the element and immediately in the first attempt itself, we are finding the element. Average case means, okay, fine, here and there we are putting some more efforts and then we are finding the element. And the worst case is that, okay, n number of attempts we have found that element. That is called the worst case scenario. But for example, let's see, let's take a more practical example. Let's say this is the unsorted array that I have, right? In this particular unsorted array, there are a number of elements are there. Let's see, some thousand of elements are there. So let's see, index is from 0 to 999. So in the best case scenario, let's say I'm looking for element 10. I'll check it. I'll come to this particular position. I'll check that, okay, yeah, 10 is available. I found it. It means in the first attempt itself, I found that element. And then the best case scenario, this is called a best case scenario. In the worst case scenario, that, okay, I'll keep checking where is 10. Let's see, 10 in that case, 10 is available here, not here. I come here and then I'll keep checking that element is there or not. So I'll keep checking each and every one. And then I found it, okay, yeah, it's available at the 999th position. So this is called the worst case scenario. And then average case scenario, let's say 10 is not available here. Then in that case, 10 is available here. Then I'll say, okay, fine, keep checking. And after a couple of attempts, then I'm getting 10 available here. Let's see, in the first attempt, I found that element. So I'll say this is my omega of 1. For example, in this case, the worst case scenario means element is available here. Then in that case, big O of n number of times I have to iterate this particular array. But let's see, in case of average case scenario, after a couple of elements, I found that element. So I'll say, okay, theta of, let's see, n number of times I have to perform. Then in that case, I found that particular element. Let's take some more simple examples. Let's see, if you are in India and you really want to travel from Kashmir to Kanyakumari, how will you do that? In the best case scenario, you will just start from this location to this location, and then you will just take this straight a road, and then you will take all the shortcuts and everything, then you will avoid tolls and everything, and then you just take the shortcuts and then you are reaching. So this is called a best case scenario. Okay, I'll say this is called a best case scenario. You have reached here. But in the average case scenario, let's see, you go to some other place, you go to Delhi, Delhi to, let's see, Rajasthan, then you go to, let's see, some other state, and then other state you are entering to Karnataka, and then Karnataka to Tamil Nadu, that you are reaching it over here. So this is what I'll say, okay, fine, this is my average case scenario. Then in the worst case scenario, that okay, these two roads are not working, or these two roads are, you are not aware of it, and then you are very new, you never traveled from Kashmir to Kanyakumari, and then in that case you take some other road. Then you take, okay, fine, I go to some, let's see, I go to some other state to, let's see, some other state, then go to this state, then go to another state, then go to this state, then go to this state, then reaching to Karnataka, and then reaching to Tamil Nadu over here, let's see, for example, like this. So what is this? I have taken a bigger path, a larger path in that case. So I'll say this is my worst case scenario. Ultimately, the result is we are reaching it over here. So same thing in the programming also, same thing in the algorithms also. When we write a specific algorithm, we have to make sure that, okay, how exactly my application or that algorithm is working fine in case of worst case scenarios. The graph representation over here, that graphical representation of the best, average, and the worst case. What we say, okay, fine, let's see, for n number of elements, it's taking the best case over here. But the worst case obviously will take more time over here. But in the average case, it's always between the best case and the average case. So here it's coming between over here, right? The average case is denoted by theta, worst case is denoted by big O, and the best case is denoted by omega over here. Remember this. If you see some examples here, see this table, it's a time complexity for the array sorting algorithms, right? And here 3 columns are there: best case, average case, and the worst case. So whenever we have to consider, let's see, there are millions of records are there. Sometime in my application, let's see, on Amazon, there are thousands of products are there, or millions of products are there, and I have to search a specific product. If I'm checking that, okay, which algorithm or which sorting algorithm or which search algorithm that I have to use, that I have to consider my worst case scenario also, that there is no guarantee that the moment I'm looking for the MacBook, it's available on the first position. Then in that case, that's a best case, right? But you have a larger and a larger number, and then the element is available at the, let's say, the last position, for example, or the product is available at the last index. Then in that case, that we have to keep traverse or keep sorting the specific array. So that's what all the sorting algorithms or different search algorithms having the 3 possible scenarios: best, average, and the worst. And then what we take it seriously, we always try to make sure that whatever the code that we are writing, make sure that my worst case scenario is having a better performance. So what we have to take, what is a normal way of calculating the time complexity, that's why we call it always big O of worst complexity. So that's what, if you see which one is the best one among all the sorting algorithm in the table, if you see it over here, among all these guys, you see that a merge sort, or you can say time sort, and the heap sort is having O of n log n. And if you see the same diagram or same graph over here, n log n somewhere is better than on square and on cube. So that's why you go back to this particular table here once again, that here we have on log n, which is a better performance as compared to on square with all these things. So that's what, whenever we have to sort, the merge sort is one of the quickest sort, or time sort, or the heap sort is one of the best sorting algorithm that we always consider. I hope it's clear. What is the difference between best, worst, and the average case scenario? If someone is asking you, please explain certain basic examples. And then we always take consideration with the worst case. We have to take this worst case scenario always seriously, so that we can write the better optimized code with our algorithms. Thank you so much.